All right, this is Mrs. Keener, and we're going to do some examples of the chain rule. The chain rule, you can never see too many examples. Each one's a little bit different, so it's good to see lots of examples. And we're going to try and get through example 4, the triple chain rule. That's where you use it 3 times. And then example 5 are the big 3. Okay, you ready? Here we go. So a triple chain rule happens when we have f of g of, look, I already made a mistake. Get your lined paper out because there's not enough room on the packet, so you're going to use lined paper to do these examples. F of g of h of x. So we have a function inside another function inside another function. You can think of it as a peanut M&M with like the outer coating, and then you have the chocolate, and then you have the nut inside, okay? So the derivative is going to go like this. You always start with the derivative of the outside. So it would be f prime, and then the inside stays the same, g of h of x. And then, how are my parentheses here? Okay, then we're going to multiply by the derivative of the inside. Well, the derivative of the inside now is g of h of x, so then we take the derivative of g, but you leave the inside alone. Then we multiply it by the derivative of h, like that. Okay, you ready? This doesn't look like a triple chain rule because it says cosine squared of 3x, but what we really need to do, we have to rewrite these. This is a very popular question to go on a test or a quiz or the AP exam. Because if you get this, you pretty much get a bunch of rules, so it's a good one to test on. Do you see how I rewrote that as we need to see the cosine of 3x is all being squared. So what's the inside function? The most inside is our 3x, and then the second layer is the cosine, and the outside layer is the square. You ready? We're going to find capital G prime. Here we go. So the derivative of the outside, the derivative of the f function on the outside, the 2 comes down in front, the inside stays the same, and we have our new power of 1. So I just took the derivative of, let's say it was x squared. The derivative of x squared would be 2x, like that. So the inside stays the same, the inside stays the same. When you're using the chain rule, the inside stays the same, like that. And then we're going to multiply by, I do these arrows just to help me, I don't know how else to remind myself that I need to multiply by the derivative of the inside. So now we're looking at the cosine of 3x. Pretend all of that has gone away. What's the derivative of the cosine of 3x? Derivative of cosine is negative sine. And because it's 3x, the inside stays the same, the inside stays the same. When you're using the chain rule, the inside stays the same. So there's our inside. Now we need to multiply by the derivative of 3x, and the derivative of 3x is 3. Do you like my beautiful parentheses? Do you have all the parentheses like me? There's no adding and subtracting. There's only this multiplication by a negative. So what we're going to do is we're going to pull out the constants and the negatives in front. So I see a 2 times negative 1 times 3 would give us negative 6 cosine of 3x times sine of 3x. And that's it. Let's try another one. Triple chain rule. So looking at my paper, I'm going to do the rewrite step here. So instead of sine squared, I'm going to say sine of 2x plus 1 squared. Derivative of the outside squared. So I'm going to bring the 2 down in front. The inside stays the same. The inside stays the same. When you're using the chain rule, the inside stays the same. Multiply by the derivative of sine of 2x plus 1. So what's the derivative of sine? Cosine. And what happens to this inside? The inside stays the same. The inside stays the same. When you're using the chain rule, the inside stays the same. So we did the power rule. 2 came down in front. The inside stayed the same. Now we're multiplying by the derivative of the inside. Derivative of sine is cosine, but the inside of that stayed the same for the second step. Now we're going to multiply by the derivative of our innermost. And what's the derivative of 2x plus 1? 2. One-step simplification. That just means you bring any negatives or numbers to the front. So we have 2 times 2 is 4. But sine times cosine stays sine times cosine. Like that. We do have time for one more, and we actually have a cube here. We have, and tangent is a little bit more complicated of a derivative. So we have the tangent of, holy moly, pi theta squared, and that is all being cubed. So you have to identify first what is the outermost function, and the outermost function will be just the cubic, the cube. So what's the derivative of, pretend this is x, x cubed. The derivative of x cubed would be 3x squared. So we're going to bring the 3 down in front. 3x squared. And what happens to the inside? Go ahead, sing it. The inside stays the same. The inside stays the same. When you're using the chain rule, the inside stays the same. Now, what's the middle function? In the middle, not all the way in the inside. So the middle function is now going to be the tangent. So we're going to multiply by the derivative of tangent, and you need to have these memorized. So the derivative of tangent is secant squared x. But it wasn't an x this time. What was on the inside of the tangent? Pi theta squared. Pi is a number. Theta is a variable. Are we finished? No. We still need to, the inside stayed the same, and now we need to multiply by the derivative of this inside. Pretend this is 3x squared. What would the derivative of 3x squared be? Well, you would do 2 times 3. So 2 pi theta to the power of 1. All right, what can we bring to the front? Pi theta squared, and pi theta squared is protected with these trig functions. So we can't move those, but we can move 2 pi theta times 3. Will be 6 pi theta tan squared times secant squared. So that's our triple chain rule. What do you think? I don't think they're that hard, but students do struggle with those, so I hope you're paying attention. Ready? We're going to go into these. So these are called the big three: product, quotient, and chain. Let's see how the three can be incorporated with each other. Find the derivative of each. So now we're going to use both of them at the same time. You see on the first one, example here, we have 5x times x plus 3 to the 1/2 power. So we're going to use the product rule here, but when we take the derivative of the second, x plus 3 to the 1/2, we're going to have to use the chain rule. Hold on. If I show my work for this one on this paper, then I might go to lined paper to show my work for these. Okay, here we go. Ready? F prime. I told you guys I still write the product rule down. It goes like this: fg prime plus gf prime. Just so I don't get lost. So f is our first group is 5x. So I leave it like that, 5x. Now g prime. Now we're going to use the chain rule here. Okay, ready? So the power rule says to bring the 1/2 down in front. The inside stays the same, and then we take 1/2 minus 1, so we get negative 1/2. Now, I apologize. This is a boring chain rule. What makes a chain rule a little bit boring? When the derivative of the inside, what's the derivative of x plus 3? It's just 1. So really, like, not an official chain rule because the derivative of the inside is 1. But we just did it to practice, okay? Plus, we're almost done. G is the second function, square root of x plus 3, times the derivative of the first. So the derivative of 5x is, sorry about that. Okay, my phone was ringing. Derivative of 5x is 5. Let's see. What should we do here? I see a 5x in the numerator, all over 2 times the square root of x plus 3, plus 5 times the square root of x plus 3, like that. And I see a plus sign, so in mathy math, we're supposed to get a common denominator. Not sure if I'm going to have time to finish all of these, but I think this is a good start. So how do I know the common well, I see this denominator. Just look at the other denominator, and that's what we need it to look like. So I have 5x plus 5 times 2 is 10. Square root of x plus 3 times the square root of x plus 3 is just x plus 3. So look at that. We got a common denominator, and then in our numerator, do you see we can distribute and combine like terms? And I'm going to just do that in one step. So 5x plus 10x would be 15x plus 30 all over 2 square root that. Okay, what was that an example of? Should we write that down? So this is a product with a chain. And this is going to be a chain with a quotient. So there's a quotient inside, Q-U-O-T-I-E-N-T, with a quotient. So let's see if I have time to do that. I don't know. Example, oh, that noise. Okay. We're at example 5, and we're on B, and I'm hoping I have time for this. Oops, sine, oh yeah, it's supposed to be an equals there. I'm writing the question. Now, derivative of the outside function is sine. So what's the derivative of sine? Derivative of sine is cosine, positive. The inside stays the same. The inside stays the same. When you're using the chain rule, the inside stays the same. So anytime you have the sign of something, we got to use the chain rule. Now, derivative of the inside. Hey, if it was just 3x, then the derivative of 3x would be 3. But it's not. It's a whole fun quotient we're going to do. You ready? Do you have a lot of room? Do you have patience? Do you have time? Here we go. Low, d high, derivative of 2x plus 1, 2, minus high, d low, derivative of the denominator, it's just 1, all over low squared. Okay, with 1 minute left, you cannot touch this. Cosine of this stays like that. The only thing we can do is distribute and combine like terms in the numerator. Thanks for watching. These are the most complicated it's going to get. So if you can handle this, then you're doing good. If you can't, I need you to come see me at lunch or after school, and we'll get some help, okay? To me, it looks like these two x's cancel, and -6 and -2. Let me know if you think there's a mistake somewhere in any of these. Feel free to email me or post a comment on Google Classroom if you notice a mistake. But to me, this looks okay. All right, thanks for watching.